Disappearing ink. Trick birthday candles that relight after extinguishing. Pushing an egg through the mouth of a bottle without breaking it. These tricks seem to defy the laws of nature, but they're not magic. One of the roles of chemistry is to demystify the unknown. So let's apply a little chemistry to reveal the mysteries behind these magic tricks.
In the case of disappearing ink, the explanation is actually pretty simple. All right, so what we're going to do next is we're going to make disappearing ink. What we have in front of us is our 4 ingredients. We have regular water, we have ethyl alcohol or ethanol, we have an acid-base indicator called phenolphthalein, and we have a strong base, sodium hydroxide. We're going to mix about 1 milliliter of phenolphthalein with 10 milliliters of ethanol. Now, Eugene, using the glass stirrer next to you, just slowly, gently start to stir that. Now, Cameron's going to add in the 90 milliliters of water. Should see it start to change a little bit. Should form a little hazy solution. Good. Cameron, using the eyedropper and the sodium hydroxide, continue to drop-wise add in that base until we see a color change. Okay, that phenolphthalein chemical that that we added in first, the 1 milliliter, that's called an acid-base indicator. It's going to change color depending on the pH of the solution we're dealing with. To tell whether a solution is acidic or basic, scientists use a quantity called pH. A solution is acidic if its pH is between 0 and 7, and is basic if its pH is between 7 and 14. A very low pH means that a solution is very acidic, and a pH close to 14 means that a solution is very basic. The sodium hydroxide that we mixed in is a very, very strong base. So if you remember your pH scales, what we've done is we've tipped the scale so that the solution in front of us is strongly basic. If we splash this mixed solution onto some cotton fabric, it's going to appear to be a very deep red stain, which would get you in a lot of trouble with the parents. But this indicator is only going to stay red as long as the solution is skewed one way. If we can bring this solution back to neutral, the color will disappear. As the solution mixes with the carbon dioxide in the air, what's going to form in solution is what's called carbonic acid. The carbonic acid and the sodium hydroxide are going to undergo an acid-base neutralization, so our pH of 7, neutral, no longer have any stain to be upset about.
Happy birthday, Mo.
Thank you. Light up my candles.
So you're 4 then?
Can I blow them out now? You guys want to sing for me?
Not really.
Happy birthday to you.
What? Wait a minute. Let me try that again.
Weeks.
All right, hold on. Yes. Woo! Eugene, no high five?
Speaks like that.
Why?
To understand how this trick works, let's see how a regular candle works. In a regular candle, the wick is saturated with wax. So when you light the candle, the flame melts, vaporizes, and ignites the wax. This burning wax then heats the wax of the main candle and melts it. Then, the liquid wax rises in the wick and is vaporized by the flame. The reason the lower part of the exposed wick does not burn, but the wax burns instead, is because the vaporizing wax cools it and prevents the wick from burning. This explains why the little part of the wick that burns is only at the tip, where the wax has completely evaporated. After the flame has been blown out, it goes out because the draft blows away the wax vapor, which was the only hot part when the candle was lit. In a magic candle, finely divided particles of metal, usually magnesium, have been added to the wick. These particles ignite easily and burn hot enough to ignite the wax vapor after the flame has been blown out. If you look up close, you can see these white hot particles flashing off the wick. No magic here, just particles of metal that help reignite the candles.
Brent, I challenge you to get that egg through the mouth of that beaker.
Sure, that should be easy.
If you try it like this, you won't have much luck.
Alright, here's how it really looked.
works. Take a small piece of paper, light it on fire. Make sure the piece of paper is burning pretty well. Drop the piece of paper into the bottle. Wait a second, put the egg on top, and make sure you have a tight seal.
Is it a tricked bottle, a tricked egg, or something else? This trick can be explained with a basic understanding of the behavior of gases. Gases are made of molecules that are relatively far apart. Unlike solids and liquids, gases do not have a defined volume, so they expand to fill any container. If the temperature of a gas in a container is raised, the molecules will move faster. The hotter, faster moving molecules hit the walls of the container with more force, so the pressure increases. This is a phenomenon called the Guy-Lussac law. All right, what happened here is that the paper burning inside with an airtight seal created by the egg used up all the oxygen in the jar. The air outside was then at a higher pressure than the air inside, and the result is that in order to balance the two out, the air outside pushed the egg in so that there's no longer an airtight seal here, and the two different pressure zones are now balanced.
Should we be disappointed that none of these tricks are actually magic?